Hey folks, here I am again, lecture 2. We are looking at describing a single variable. This is our second lecture of 9. So here we go. All right, so this is a lecture that you're going to have to come back to. Well, every lecture you're going to have to come back to, and I've been doing this since 2012, and for that reason, a couple of years ago, I decided to start making videos so that people can come back to it. So use and abuse this, take full advantage of these videos in terms of stopping, replaying, what did she just say, replaying, right? Because that's what it's here for, and nobody knows that you're doing it. So use it as frequently as you'd like. Call me also, but this is a quicker way, right, to get exactly what you want answered, because I try to be as thorough as I can be. So lecture 2, describing a single variable. We have gone from lecture 1 where we understand what the variable is, right? We know what a variable is now. It's a question, right? It's the basic question that any study will ask you. What's your name, or what's your age, or what's your race? How old are you? I already said that. Anything. What do you like about this class? I love the professor. That's what I love about this class, right? And I love all the important information that I'm learning about this course. So today, now that we know what a variable is, we're going to try to describe this variable, because describing it is absolutely important, and not just knowing what it is, right? So here we go. Let's describe it. There are many ways to describe, to summarize variables, particularly numerical variables. So we've looked at interval variables, which again are numerical variables, and we've looked at categorical variables. Today we're going to look at numerical variables today, okay? And if it's a categorical variable, we're going to talk about it in terms of if it were numbers. Bear with me. So in order to learn how the values of a variable are distributed, we can ask a number of questions. We could ask, what are the most typical values that we see in this variable? What does that mean? What age range is the most typical that we see here? So we see that most people said 41 to 50. The second most typical was, 31 to 40, right? But the most typical, right, that's what we are asking. We call that a mode. These are things also, this lecture 2 is a lecture that you got in elementary school. So you understand means and medians and modes. You understand what a range is, but we're going to look at it and it's going to feel so much different because we're looking at it from a statistical point of view, even though all of these terms are statistics terms, but we're going to look at it through frequency tables, something that we've probably never done. And so we're going to do that in lecture 2. And so while this is something you feel like you're going to, hopefully you're not going to feel frustrated that you're like, why don't I understand that? You're going to understand it. Don't worry, you will understand it. So how spread out values are, we know the range. We've probably heard of the standard deviation. Today we're going to learn what that actually means. What are the extreme values on either side, right? It could be a minimum, the maximum. It could be an outlier either at the minimum level or the maximum level. And then is the chart of the values symmetric about some middle value, or is it skewed in some direction? Does it have, sorry, scratching my toes, does it have any other peculiar features besides possible skewness? So what all of that essentially means is how centered is it? What's the average? That's another word for mean. What's the middle? That's another word for median. So we're going to learn what all these things mean. Okay, So definitions, just like we did in lecture 1. Definitions for lecture 2, we always have to know, understand what, we have to be speaking the same language, right? So these are our definitions. For measure of central tendency, we use mode, median, and mean. We simplify data even further than frequency distributions and charts by providing measures of center. Measures of center. Okay, the mode is the most common or most frequent value for a variable. The median is the middle observation. You take everything, you put it in order. For example, you say, everyone get in height order. Put it in order. So they get in height order, right? And you count off and you see where the middle is, and that's the median height. It's the median height. It's that simple. And then the most sophisticated of the centers, right? Because we've got the, how many people said they're this age and this many people said that, and that's the maximum, right? The most common value. Then you've got the everyone put yourself in order and let's find the middle point. And then we've got the more sophisticated form of mean, and that is the most sophisticated form of center. And that's your mean, that's your average, right? We know that we add all the numbers up, we divide by the total number of numbers that we added up, right? And that's our average, that's our average. Okay, and then we have the measures of dispersion. Another way of saying that, how spread out that variable is from the center. Okay, how spread out is it? The range, the most basic form of spread, right? Maximum minus minimum. That's it. Highest minus the lowest value, right? And we're talking values. And so the standard deviation is how spread out something is from the mean, the average. So we get the average, and this spread deals with the how spread out it is around that average. The interquartile range is one you've probably never heard of, and it's how spread out something is from the middle. We know the middle is our median. So how spread out that variable is from the median. So all of these three are forms of spread. So if something has a spread of 3 and another thing has a spread of 7, then which one is more spread out? Right? The one that's 7, because that's the higher number. So regardless of whether you're looking at range, standard deviation, or interquartile range, IQR is what we call it. If one IQR is higher than another IQR, then that's probably that one is more spread out than the other. Just that simple. Okay, so let's look at an example of the mode, one of our forms of measures of central tendency. Again, this is the value in the data set with the largest number of cases. We know cases is another word for observation, right? So to find the mode, determine which value has the highest frequency in the table, in the data set. So let's look at this as if we're looking at Excel. In Excel, observation would be here, and we'd see 1, 2, 3, 4, 5 going down, right? In Excel, the next column would be midterm grade. Midterm grade at the top, then we'd see A, B, A, B, A, B, C, B, B, C. So because of space, I wasn't able to do it vertically, so I did it horizontally. So, but imagine that you're looking at an Excel spreadsheet, okay? So now, how many people responded to the survey? Hopefully you're saying 10. So 10 people responded to the survey. Person 1, it's not even a survey. The professor seems to be the one doing this study. So person 1 got an A, person 2 got a B, person 9 got a B, person 10 got a C, right? We can see that. We can look at the data set and understand, right, the different observations here. We can look at this data set and see that there's one variable, what is your midterm grade? And we have several values, 3 to be exact, A, B, C, 3, okay? A is repeated, B is repeated, throughout, and we see C is also repeated. But we have 3 distinct values. Okay, good thing nobody got F's. I'm happy. All right, so which type of variables can modes be used on? Well, they can be used on categorical variables. They can be used on interval variables. They can be used on all variables, right? But which one would we probably in real life see modes used on? Categorical variables. So a variable like religion, what value is the mode for that question religion? So we just look and we go, okay, well, the one that we see most here is, I don't know, agnostic. So boom, that's our mode, the one we see most frequently. The one we see next most frequently, maybe we say, oh, okay, it's Christian. All right, boom, right? So, so this, in this example, sorry, you already saw the answer, but for this particular example, what would the mode be? The mode would be, hopefully you're counting and you can see there are 1, 2, 3 A's. We'll have more A's in my course. There are 1, 2, 3, 4, 5 B's, and we can see 1, 2 C's. So B, there are 5 B's, so that's the most that we see. So B is our mode. Let's look at another example. What's our mode here? We see 142, 139, 122.6, 122.5. Wow, so it's just one of everything. So what does that mean? Well, it means that they're all modes, or it means that none of them are modes, whichever you decide. Okay, so they're all modes, but none of them are modes. Okay, whatever you decide, because they're all seen there once. The purpose of a mode is to point out the one that sticks out. So in this case, I would say there's no mode, right? Because, I mean, even though I am saying there are more than one modes, technically there are, right? But for the purpose of the study, does one stand out, right? Is the data more centered on one than the other? No, the answer is no, right? So let's go on to median, because mean is the most basic form of center. Then we go a little further to median, gets a little bit more complex, right? The median, as we knew from 5th grade, the median is the middle, right? You take a pie, you cut it in half, right? And that's the middle, that's the median. You take a Snicker bar, you make sure you cut that thing in half, because if you don't, if you were like me and my siblings growing up, if it was just, oh, she got a little bit more than me, right? So it's not the median. It's, you know, but at the very center, that's the median. Now, we know that conceptually, but now we have to put it to statistical terms, okay? Because we don't just have a ruler and we're cutting in half, a Snicker bar and we're cutting it in half, right? A pizza pie, I'm cutting it in half. No, we have 5,000 observations, okay? And we're not gonna go to each of them and say, hey, get in order by height, then let me cut, then, okay, this is the middle point of that. We're not gonna do that. We don't have time for that. We have statistics to do. We have statistical software that assists us in doing our statistics. So what are we gonna do? Well, we're gonna just use this basic equation. We put it in order. Now we're going to count the number of observations, and then we're going to do this basic equation, n plus 1 over 2. And at that point, that n plus 1 over 2 observation, that is our median. So let's give it a try. All right, so in this case, we have 6, not 5,000, but 6 observations. We can count it 1, 2, 3, 4, 5, 6, right? Clerk 1, secretary, director, clerk 2, assistant director, clerk 3. That's 6. So our N, anytime you see N, that means what's your number of observations? In this case, 6. Awesome. How many variables do we have? I'm going to keep practicing this. We have 2 variables. One variable is what's your position, right? The question is, what's your position? The other question is, what's your salary? What type of variable is position? Hopefully you're saying nominal. You could even say, you could even say ordinal. because assistant director is probably higher than clerk 1, right? Director is probably higher than assistant director. So we would probably say ordinal. It's categories. There are no numbers here, so it's not interval. It's categories, right? And these categories have some order about it, I guess, right? If we're thinking about salary, it might have some order. We could also say maybe, oh, we can't say, sorry, that's a dummy variable because there's more than 2 cases here. We see clerk 1, none of them repeat. It's only just 2. I mean, it's 6 values, not 2. So it's not a dummy. It's just ordinal or nominal, whatever you decide in this particular case. And so it's a categorical variable. The second variable, salary, we can see right off the bat that it's numerical numbers here that we're seeing, so it's interval. It's an interval variable. All right. So now, what is our median? Well, if we took this as is and we cut it in half, so in the middle we go 1, 2, 3 down, we go 1, 2, 3 up, 1, 2, 3 down, 1, 2, 3 up. The 1, 2, 3 down gets us to 42.5. The 1, 2, 3 up gets us to 22.5. So the median would be in the middle of those two, and we would say 32,500. No, we absolutely wouldn't say that. We absolutely wouldn't say that. Why? Because we missed the first step. The first step. The first step says put them in order. If we're trying to get the median salary, then we need to put salary in order. So that means that we would start with 17.5, then go to 22,400, 22,500, 22,600, right? Or we could start with 45,500, 42,500. Then we would go to 39,500. Then we go to 22,600, and so on. So we could start with the lowest to highest. We could start with the highest to lowest, whatever. We just need it in order, right? And then we count to the number of ends. In this case, we had 6. We did the equation 6 plus 1 is 7. 7 divided by 2, that gave us our 3.5. That's why we went 1, 2, 3, 1, 2, 3, and then we counted in the middle. We needed the halfway point, right? So that halfway point we thought would be 32,500. But because we didn't do the first step, that answer is incorrect. Okay, it's not in order. So then we go and put it in order. Yay! And we seem to have put it in descending order, to the highest to the lowest. So what do we see now? We've done the first step. The second step is to count the number of ends. It's still 6. The third step, we've already done it because it's 7 plus 1 over 2. That's 3.5. So whether you go 1, 2, 3 or 1, 2, 3, that halfway point is now at the 3.5 mark, right? And it's between 22.6 and 22.5. So our median is not 32,500. Our median, our middle point of salary is 22,500. Okay? Awesome. So let's look at another example. Again, we're visualizing not horizontal but vertical, that we're looking at an Excel spreadsheet, and we put this in order. It's currently not in order because we've got A, B, then we go down, then we go back up, then we go down, then we go up, and then down again. Boop. Nope, no order there, none at all. So let's do first step, put it in order. So now we've got all the A's first, then we've got the B's, then we got the C's. Let's make sure that it's in, that we've got this right number of A's. It should be 5, 1, 2, 3, 4, 5. Yep, B's is 3, C's is 2. Let this be the distribution, and maybe just not any C's at all in my course. Please do the work. Okay, so now it's in order, and now let's count the number of observations. Well, we've got column 1 already telling us, in this case, row 1, right? But we've got it telling us how many people. Person 1 had an A, person 2, and so on, right? So we can see that there are 10 observations. So now, what do we do? N plus 1 over 2, so 10 plus 1, 11 over 2 5.5, right? So at the 5.5 mark, let's go 5.5. So that's between person 5 and person 6. That 5.5 mark is between person with the A and person with the B. So our median, we would say, is somewhere between an A and B, right? A minus, B plus, somewhere in between. And let's make this, notice the note that I placed here. Use the number of frequencies, not the number of categories. So N is the number of observations, not the number of values. There are 3 values here, A, B, and C. We wouldn't say, oh, let's make it 3 plus 1, which is 4 over 2, which is 2. And so, like, what would 2 be? We would go to category, we would go to observation number 2 and say, oh, the median is an A. Oh, I don't know what that means, right? No, that's wrong. That's totally wrong. We would say N plus 1, N being the total number of people answering this survey, right? And so, and not the total number of values for the midterm grade. It's the total number of people, not the total number of answers, values, right? So not A, B, and C, but person 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? This is really important because once we start looking at it from, it sounds very basic, but I promise you, I've seen this for 5 years now, where people use frequencies and not, categories and not the frequencies. So we're not going to do that, but we're going to get through how to not do that, okay? Now the third thing we're going to look at in terms of central tendency is the mean, also known as the average to a layperson. The mean, we know, we just add up all the points, we divide by the total number of people, right? And we get our mean. Just that simple. So what do we have? We have, okay, so first off, we've got our data set, right? Gender now, it's actually in the way you would see it in Excel, gender and all the values, weight and all the values. Okay, so gender is a variable. It's got 2 categories, male and female. Weight is a variable, and it's got several different values. It's got 100, 200, 150, 250, right? So we know, without even being in this class, that to get the average, we would say 100 plus 200 plus 150 plus 200 plus 250 plus 100, add all of that up, and now take that number divided by the N. So N is 1, 2, 3, 4, 5, 6. 6 people are in this survey, so 6. So take all of those numbers we just added, divided by 6, we should get the mean of 166.67, right? So what does this thing mean up at the top? What in the world is that, right? This, oh, where am I? Trying to pull up something here. So this right here, I'm sorry, that's the first time I'm using this. So that right there should not scare you in any way, because we're going to go over what that means. So this, how do I do that? Let's go with this. So this here, X bar, is, and we call it X bar. X bar is mean, okay? That E symbol is a sigma. It's a Greek, it's a sigma Greek term for add. That's add. That's our plus sign, essentially, it means add. Okay, X1, Xi, excuse me, is the value, is each of these values, 100, 150, 200, and then N, we already knew, is the number of observations. We know that, old news, right? So this is an equation for mean, okay? So it's saying you take all those Xi's, you take all those numbers you see there, you add them all up, because that's what the sigma means, and then you divide it by the number of observations, in this case 6. That's it. Okay. I gotta cancel, gotta get out of here. Clear all drawings. It won't clear. Okay. There we go. All right, so here's another example. Sorry, guys. So here's another example. We've got 2 more variables, right? One variable is position. What's your position? We've already seen this variable. We saw this other variable, salary. What's your salary? And they told us exactly what their salary was. Aren't they helpful? So now we want to take the mean of salary, right? Not of position, because we don't have actual numbers there. So let's take the mean of salary. What would we do? Well, we just add them all up, 42.5, 39.5, add all of those numbers up, divide by, again, 6. So we should get our number. Yay. All right. Now, it gets a little complicated, just a little bit. We take this numbers, and we're going to do something different because we know frequency tables. And really, I should have shown you guys a frequency table here. But it's okay, because we're going to get through it, and then we're going to see it in our homework in an Excel form as a frequency table. So it's all good. Oh, and in our practice. Duh. Okay. So this equation, it should look the same. The only thing that should change here now, that looks different now, is let's highlight this. It just snuck right in there, didn't it? Totally snuck in there. And so what does that mean? That means frequency. So we have a frequency. So right now we're looking at an Excel spreadsheet. Okay, the Excel spreadsheet shows us that 10 people responded. We see the 10 grades for this for these 10 people, right? Their final grades. Before, these grades were letters. Now they're numbers. Yay! And so in a frequency table, you would see it the way you see like in the orange here, right? You would see 100, and then in the next column you would see 1. You would see 90, and how many people got 90? 4. You would see 80, 3. You would see 70 under frequency. You would see 72, right? 2 people got a 70. 3 people got an 80. 4 people got a 90. 1 person got 100, right? So we would see that in our frequency table. Let's clear this out. But let's explain what the F means, because we already know X bar is the mean. We know N is the number of observations. XI is just all of those values. And that sigma sign is just add up all those values. But rather than add up all those values, what we're going to do now is we're going to just say the value times 1. Because in a frequency table, we're just going to say 100. We see it 1 time. How many times do we see 90? 4 times, right? This is basic elementary school stuff, right? This is nothing new. So we can go 90 plus 90 plus 90 plus 90. Or we can say 90 times 4. Same thing. So that's the only thing that this FI means. That's it. It's just saying, let's not just add up for no reason when we can shorten our process by doing that number times however many times we see it. And that number times however many times we see it. And then that other number times however many times we see it. That's it. Just multiplication. Rather than adding everything, we multiply and add. Okay, so here we go. So here, what would our mode be? What would our mode be for this? If we remember that mode means the one that we see the most, the value that we see the most, we can look here, or we can look in our summary frequency table, which would not look like this, right? It would be an actual table. We would see that the one we see the most is 4 because we see it 4, is 90 because we see it 4 times. 90, right? We see 100 only once, 80 only 3 times, but 90 we see 4. So our mode would be 90%, okay? What would our median be? Well, this is already in order. Thank you, Dr. Kalechi Uzuchukwu, for putting this in order. So how would we do that? Well, we can do it a couple of ways, right? We can look at this, and because it's not 10,000 observations, it's only 10, we can say, hey, we're going to cut it in half. What would we cut it in half, right? Well, how we cut it in half? We would do n plus 1 times divided by 2. So n, that's 10, plus 1, that's 11, divided by 2, that's 5.5. So here we are in between that 90 and 80, and our mean would be an 85, right? 5.5 would be in between 90 and 80, right? Or we could look here at our frequency table that would be a frequency table in another life. And we can see, again, we already know it's in order, 190, 80, 70. We would take our n plus 1, right? Which is 11 over 1 over 2, it's 5.5. Still, nothing's changed. So we would go 1 plus 5, that's 5. So we would need to go between 5 and then 6, 7, 8, 9, 10. Let me put this annotation thing up again. So that would be 6 from 100 to 90. That's 5. 1 plus 4, right? 5. And we can see it here. 1, 2, 3, 4, 5. Right? And then we have 6, 7, 8, that's 3. So at 5.5 would be between 90 and 80. Either way, we could see it all laid out, but we would never want to see that if it's 10,000 observations. Even if it's 100, we wouldn't want to see that. We're just happening to want to see that because our cases are so few. But in a real data set, you're not going to want to see the Excel version. You're going to want to see the frequency summarized version and say, okay, we need the number, 5.5. Well, we've got 5 here, so 6 must be here. So between 90 and 80, which is 85. All right, now let's look at the reason why we're on this slide to begin with. This F, right? This F just showed up out of nowhere. It's trying to frustrate our lives, but it absolutely is not going to do that. It's actually here to help us. So rather than look at an Excel spreadsheet, right, we go, okay, here's our frequency table. We do frequency of 1 times our x1, our value 1, our first value of 100. So 100 times 1, which is 100. 90, which is our next value, times 4. 80 times 3. 70 times 2. We add all of that together, right? We divide by how many? Hopefully, by the grace of Almighty God, you didn't just count 1, 2, 3, 4 and divide by 4. Hopefully, you went to the frequencies and saw, oh, it's 1 person here. Okay, it's 4 people here, so that's 5. Plus an extra 3 people here, okay, that's 8. Plus 2 people here, that's 10, right? So we could either see it out like this, where we see all 10 people or all 10,000 people, or we could see it here where this says 100 and then 400 and 300 and 200, or in this case, 1, 4, 3, and 2. And we know that we add all those numbers up, all the frequencies, the Fs, we add all the Fs up, divide, and that's what our N is. We divide it by the N. Okay? So while our mode was 90, very high, our median, when we took it, put everybody in order, our midpoint was 85. Our mean is a little lower. So our data seems to be skewed a bit more to the left, okay? Heavier on the left, because it's an average, it's weighted now, right? It's not just, just sort of simplistically saying how many people got the highest or had this highest number, had the highest frequency, or, oh, what's the midpoint, right? It's a little bit more sophisticated, and so it's weighted now, okay? All right, so let's look at this. Here's a frequency table, like legitimately frequency table. Yay, we don't have to imagine anymore. Imagination is good. But we don't have to imagine anymore. So here we go. We've got a frequency table. What are these two things? Hopefully, you're looking at the years of education and saying, I know this is a frequency table and it has one variable, and that variable for this particular table is years of education. So people are responding, answering the question about how many years of education do you have? And I know the arrow going down is the answers to the question, right? The values, okay? So now that we know that, we know what we're looking at. We're looking at years of education. Someone said they have 10, probably, yeah, so 10. So that means they dropped out at 10th grade. Someone finished, right? Got 12 years of education. Someone may have gone to technical school or dropped out of 4-year college. Someone did 14 years, 15, 16 got their bachelor's, yay. 18 maybe working on that master's and PA, and 20 maybe a second master's, maybe a PhD, right? So what else do we know? We do know that there are the total number of observations, right? We can look and see it's 1,000. How many people said that they dropped out at 10th grade? 12. How many people said that they have 18 years of education? 112. So we see in frequency that those aren't values. They're just telling us how many people said those values, right? So how many people are in the data set? 1,000. Why do I keep doing that? All right, and then now we have the first question. What's our mode? If we remember, mode means then the value that we see the most. Well, we see 10, 12 times. We see 12, 330 times. We see 13, 101 times. So which one do we see the most? Hopefully you're saying 12. So the most frequent value that we see here is a high school diploma. High school diploma, right? We, in this case, we even see this is a bimodal data set, actually, because even though we see most people, the most frequent value is a high school degree, diploma, we also see that the second most frequent is a college degree, 290. So it's bimodal. Like one is higher than the other one, but it's like it goes up and then down, and then up, and then down, right? So it's two little humps in this whole chart. If we were to look at a chart, it's one hump here, and then it just kind of goes like, you know what you see, like the heart rate type thing that you see in ER or some medical, show. All right, so now let's answer the next question. You know what's coming up. It's median, right? So median, we know median is the midpoint. So we know that if this was all in one line, right, that we would be looking to cut it in half, right? What's the midpoint? But it's not all in one line. I mean, it technically is. It's a frequency table. It's all organized in one way. Like it's got the lowest to the highest. So it's already in order for us. Woo! Thank you, frequency table, for doing that for us. So now it's all in order. And so what do? We do n plus 1. First, we note what our n is. We've already noted it's 1,000. Plus 1, that's 1,001. Divided by 2, that's 500.5. Now, it's interesting because we keep getting all these even numbers and then having to divide by an odd number. But say the number is 999 for n. So then in that case, we would have n plus 1, which is 1,000, right? 1,000 divided by 2 is 500. So boom, we wouldn't have to be finding the halfway point, like 0.5. We would just find that observation, and that exact observation is our midpoint, just like that. So for example, in this case, our n plus 1 over 2 is 500.5. How would we do that here? It's not in a straight line or straight set Excel spreadsheet line, right? We're looking at an actual frequency table. Tell me, how do we get that? Well, we did it sort of in the last, well, we did do it in the last example, but here we go. So what do? The first, everyone's in order, remember? So we're looking for 500.5. We've got 12. Are we at 500.5 yet? No, because we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're only at 12. So now we're at 12. We need to keep counting. 13, 14, 15, 16, 17. So at 13, we're now at 12 years of education. At 13, at 14, we're still at 12. At 15, we're still at 12. We're still at 12 until we get through the 330 people that said I have 12 years of education, right? We just got through the 12 people. Now we need to get through the 330 people. Once we get through 330 people, how many people will we have gotten through? 330 plus 12, that's 342. So we're at 342. Have we reached our n plus 1 over 2 of 500.5? No, we haven't. So let's keep going, right? 342 plus 101, that is 443. Have we gotten there to 500 yet? Nope, 443, that's where we are. Once we end the line and finish with all the 13 years of education people, we're still at 443. Okay, now we're going to 14 years of education. At 14 years of education, we are now over at 443. Now we're at like 542. 541. Yeah, 541. 541. So we have now come into 500, 501, 502, 503, all the way to 541. So where's our mode? Our mode is in that 14. Our mode is there. Like we went all the way through the line and whew, right there, 500 observation is at 14. 501 observation is at 14. So the 500.5 observation is at 14. So that made our life easy, right? So now what do we do with our mean? With our mean, what we're doing, just like we saw on the last slide, our frequency times our value. Our frequency times our value. Because we could say 10 plus 10 plus 10 plus 10. Yeah, we'll keep going. Plus 10 plus 10 plus 10 plus 10 plus 10 plus 10. 2 more plus 10 plus 10. So we could do that 12 times. Hey, if that's what you want to do, go for it. You know, no judgment here. But me, I'm going to go with that ladder equation. 10 times 12. Done. 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 I'm done. I'm done. I'm done. On to the next. 12 times 330, right? And I can keep going. 13 times 101. Yeah, I should keep going. 14 times 98. Right? I do that all the way till I get to 20 times 18. I add all of those things that I just multiplied and got the answer for. I add all of them up. And now what? I should be dividing by something, right? And that something is n. What did we already know, decide that our n is? Our n is 1,000. 1,000 people answered this particular question. So n, so all those numbers, 10 times 12, 12 times 330, 13 times 101, plus 14 times 98, plus 15 times 39, plus 6, right? All of that divided by n, 1,000. And there we will find our mean. So our mean now, our mode was 12, our middle point was 14, and now our mean is not on this side like it was the last time. It's on this side, so it's skewed a little to the right. So these are the 3 different ways that we can think about and determine center, how centered that variable is. Okay, so we've looked at it in the form of, say, an Excel spreadsheet, right? It's another example, Excel spreadsheet. And now we're looking at it in the form of a frequency table, okay? But either way, we're gonna arrive at the exact same answers, okay? All right, so now let's go to measures of dispersion. Again, I said dispersion means the same thing as spread, how spread out something is. Oh, measures of spread, or measures, or how distributed something is, right? Range, max minus min. Note here the importance of what I'm hovering over now, value. Highest value minus lowest value. So what value is the highest here? The only values I see are 10, 12, 13, 14, 15, and so on. So the highest value is 20. The lowest value is, to the question of how many years of education do you have, the lowest value is 10. 10 years of education, I dropped out at the 10th grade, right? Or, as some people I know have done, which is completely incorrect, you say the range is the max minus the min, and they go with the maximum frequency. Does that say frequency though? Nope, nope, doesn't say it there, doesn't say it there. Maximum, they incorrectly say it's the maximum frequency minus the minimum frequency. So let's take a look at that. So their maximum would be 330 minus their minimum of 12. So your range would be years of education of 330. Nobody even lives that long these days. Talk of, you know, having 330 years of education as your maximum. My God, who are you, Moses? I don't know, but that is not what this data set is telling us. So our maximum value for years of education is 20. Our minimum value for years of education is 10, right? So that's really important. And so that's just the basic range, but we're going to do the same thing with IQR. We're going to do the same thing with standard deviation. Everything we are dealing with has to do with our values, not frequency. Our frequencies just help us to do some multiplications, help us to figure out, okay, where is the halfway point? But that is not, it means nothing else, right? Values help us understand the question, okay? All right, so then we do IQR, we do standard deviation, and note here that the IQR is the third quartile minus the first quartile. Again, it's a range, right? Just like we see range here, we see range here in this, we don't see range, but deviation is range, okay? So we're gonna learn what first and third quartile mean. We're going to learn what 75th percentile and 25th percentile mean. And it is less sensitive to extreme values than, say, the range, because the range could have an outlier, right? And then we look at standard deviation, which tends to be focused on the mean, right? The range deals with max and min. The IQR deals with the median. And then the standard deviation deals with the mean. It's the weighted mean. Okay, so these are in terms of less sophisticated to most sophisticated form of dispersion, of spread. So I just want to point out here, the more spread out the distribution is, the larger the measures of spread will be. We've talked about this before, so we're not going to mention it again. All right, so let's look at percentiles. For any percentile P, the pth percentile is the value such that the percentage P of all values, P of all values are less than it. I'm going to say it again, and I hope that it means something to you. If it doesn't, we'll talk about it. That's why I'm laughing, because it just sounds like a whole lot of craziness and it means nothing. But then when we talk about it, then people go, oh, okay. So for any percentage P, the pth percentile is the value such that a percentage P of all values are less than it. See, this is what statisticians and mathematicians do. But in this class, we're going to learn to say things in layman's terms, okay? What that sentence means. Has anybody ever taken an SAT, a GRE? Has anyone ever had a baby? Or anything where someone said, oh, you're at the 95th percentile. Or, oh, your child is at the 75th percentile of height for all the babies that were born during this time period. What did that mean to you? Hopefully that had some meaning, or hopefully you said, Doc, I don't know what you're talking about, you know? But what does that mean? So in layman's terms, what that means is if they said, oh, you scored at 95th percentile of everyone who took the SAT, well, that means you did better than 95% of people. So you did better than all the values that are less than 95%. If you're at 95%, so you would be on this chart like right here somewhere, right? If you're at 95%, you did better than everybody here because this is in order, right? From minimum to maximum. So you did better than everybody here. If you're at the 25th percentile, who did you do better than? 25% of the people. Okay? If your child was born at the 58th percentile, they are taller or maybe weighed more, whatever that percentile is about. They weighed more than 58% of the people, or longer, because they always do the height. They stretch the baby, the newborn, and so you're taller. Your child is taller than that many people, right? That were born during that time. Okay, so that's what it means now. Woo, that's what it means now. Okay, so anytime you ever hear that, now you'll know. I know what you're talking about. I know what you're talking about, player. You ain't trying to, So you'll know. So the quartiles divide the data into 4 groups. We know that because we know that a quarter is 4 quarters equals $1. Quarter 1, quarter 2, quarter 3, quarter 4. So here's quarter 1 of the basketball game. We just went from dollars to basketball games. But quarter 1, here's quarter 2. At the end of the first quarter, at the end of the second quarter is the first half is over, right? So the median, look at what we just found. The median is in the halfway point. The median is at the halfway point, but we already knew that. We totally knew that. Right? So the first quarter, the second quarter make up the first half. Okay? The second quarter, yes, we know it as the median, the second, or the medium. But the second quarter is also the 50th percentile. Right? That makes total sense now because we just made the halfway point. Right? First half is over. Go to the locker room, get ready for the second half. What do we have in the second half? Well, we've got the third quarter. Once we're done with the third quarter, we're done with 75% of the game. When we've given someone 3 quarters, we've given them 75 cents, right? And then, of course, 100% is at the max, 0% is at the min, right? So now we're looking at this data, and we can, this little chart that I created, because I think it simplifies everything. We can see range, max and min, and we can see interquartile range, IQR, and it's the middle 50%. And hopefully you can see that, right? Because the median is at the 50% mark. But then if we stop looking at anything past the median and just look at the min to the median, when we take that and we cut it in half, that gives us our first quartile, or that gives us 25% of our data. Okay, the first half, you cut it in half, that's our first quartile, or 25% of the data. Or the median of the first half, right? Whatever you want to call it that makes sense to you. But it is the median of the first half, right? Because the median, all it means is the halfway point. So for the first half, the median of the halfway point, of the median of the first half is the first quartile. The median of the first half is the 25th percentile. We can go to the second half. The median, the midway point of the second half is 75%. The midway point of the second half is our third quartile, right? So everything we've talked about is here, right here in these 4 bullet points, okay? Now, this looks like a lot. It's not. It's totally not. But let's look first at the very bottom here where it says S, standard deviation equals, okay? That is the purpose of this slide. But before we can get there, I want us to understand all of the different elements of this slide, of this equation, just like we did with mean, right? We looked at the equation, it looked like, what the heck is that? But we now understood that n meant number of observations. We now understood that that E, that weird E sign, oh, that's sigma, and it means plus. It means add everything up, right? And that xi, that just meant, oh, the value, just the value, right? And then x bar, that's the average, the mean. So all we're doing in the table that you see here, all it is breaking down that equation so that you can see how every little step is gotten. Not to confuse you, actually to clarify for you. So we're not gonna hyperventilate, we're gonna woosah. And we're gonna look at column 1 and 2. Column 1 is our I. I means observation number, right? Observation, how many observations are there? Hopefully you're counting all the I's, or you can just go to the bottom and see, oh, 14. So we see here, number of observations is 14. So when we come here, we should automatically know what we're gonna type in here. It's 14. Good so far? All right, so now we've got our xi. Well, guess what? It's right here. This is an Excel spreadsheet. If we forget that this exists, right? Everything after these first 2 columns are our Excel spreadsheet, essentially. So we take all these numbers and we add them up. Okay, first, I'm getting ahead of myself. We look at all these numbers and we find out what the mode is. What's the mode? Well, we can look at all of them and we can see, okay, 59 is only 1, 60 is only 1. So far, those are the modes. 61 is also only once, okay. 62, well, it just knocked them all out because 62 is twice. 63 is 3 times, 64 is twice. So we can look and we see that our mode is 63 because 63 is on there 3 times. That's the most that we see a value, right? Our median, it's already in order, thank you, Jesus, right? Now we can do our n plus 1 over 2, right? Oh gosh, I thought it was here. N plus 1, n, we already know is 14, plus 1, that's 15 over 2, so that's 7.5. We just keep doing these halves, I don't know. But we keep getting even numbers. So, all right, so 7.5, so that would leave us right here between 7 and 8. 7.5, luckily we don't have to do much math because 7 is 63, 8 is 63. What's between 63 and 63? Well, 63, right? So our median is 63. It's that simple, right? Now our mean, right? So we see it here, but we also see it down here. We were able to, and on Excel, all you literally would have to do is type in the word equal, type in equal, and select, type in average, equal average. You select this column, right, and press enter, and now it gives you a mean, right? Or if you don't have Excel, all we're doing is adding 59 plus 60 plus 61 plus 2 times 62 plus 1, 2, 3 times 63, 2 times 64, 65 plus 66 plus 67, right? We add all those up, and what do we divide by? Oh, and plus 68, sorry, folks. We add them all up, and we divide by 14, because that is our n, and that n hasn't changed, right? And we get 63.4. So now we've gotten all of our measures of central tendency, how centered it is. Our mode of 63, our median of 63, our mean slightly higher at 63.5. What's our range? Well, hopefully you're not looking at I because that's not values. Hopefully you're looking at xi because those are values. And it's telling us that our maximum value is 68, our minimum value is 59, and so our range would be 68 minus 59, which would give us 9. Our first and third quartile, we could do it, right? Because we have our median, and we know the first quartile is the median of the first half, and then the second quartile, median of the second half, right? So We're not going to do it. You can definitely do it because I've already done it, and you can just check your answers based on it, right? And the only thing that you would have to do here is remember that your median is 63. So you would have to include that 7.5, right, when you start counting the 1, 2, 3, 4, 5, 6, 7, plus that half. So now that's 8. 8 plus 1 over 2, right? 8 plus 1, that's 9 over 2, that's 4.5. So it should be at 1, 2, 3, 4.5. So between 62 and 62, so it's 62. I said I wasn't going to do it, and I did it for you guys. Okay, so I'm going to let you do the second half to get the third quartile, because now I know that you'll be able to do it. All right, so the third column here, all we do is take this mean, we transfer it over to the third column, because what we want to do is what this equation is telling us. We take our number, our value, so we subtract mean, our average. So we take our number, we subtract the average, and we get that. We take the next number, we subtract that average, and we get that. So 59 minus 63 should give us negative, right? 4.4. 60 minus 63 should give us negative 3.4, and so on. So that's all you're seeing here. We finally get to the positive because 64, the number, the value is actually higher than the mean. So we're finally hitting the positive notes, right? But what we'll do now is take these numbers. You see this equation is telling us to square it. So that's it. We're just squaring it. So we went from step 1 where we got our mean. Step 2, we did that quick difference. Step 3, we squared that difference. Everything you square, right, should give you a positive. So 2 negatives, when you multiply them, gives you a positive, right? And so step 4, here we are. We just take the sum of the squares. So what does that mean? We just add them all up, because that's what that E means. That sigma means you add it all up. So we added all of our squares. We added it up. Step 4 gives us 85.2. Now we're literally completely done with this second part. So let's look at the first part. The first part, all it means is that we divide everything that we just did by n minus 1. So n minus 1 is 13, because we know n is 14, minus 1 is 13, right? So we do our sum of squared deviations, which is s squared, right? We already got that. Divide by our n minus 1, and it should give us 6.6. We take the square root of that, and we should get 2.6. Okay? All right. So we've gotten through this slide, all of the components of this slide. Does that even mean anything to you yet? Probably not. I take you through this, not so that you can memorize it, but so that you know that this is something you can actually calculate. Do we ever calculate it at this point forward? No. The answer is no. The answer, again, just in case you're wondering, or you don't believe me, is no. You will never calculate this, not for me. Because we live in the 21st century, actually, right? Where we don't have to be concerned about doing things that the calculator does for us. What I do want you to know is what this means. What this means. So we're going to look in the next couple of slides at what the standard deviation means, because we understand what mean, median, and mode mean. We understand what range is, max minus min. We understand how spread out it is based on the middle 50%, the IQR. But now, goodness gracious, what is this? What does the standard deviation mean? What the heck, right? And so this 2.6 that we just calculated, what in the world does it mean? Okay, remember it's still about spread, right? So if this one has a standard deviation of 2.6, another one might have a standard deviation of 3.8. So which one is more spread out? Well, the one with 3.8, because it's still a measure of spread. So that variable would be more spread out than this one. Okay? All right. So what does it mean? What does it mean? Well, the first thing that we want to look at is this normal distribution curve. This normal distribution curve is what data should look like. If it's randomly selected and if it's normally distributed, then most of the data would fall in the middle, right there, right? Right here in the middle between 1 and 1, -1 and 1, or even -2 and 2, but then we've got little stragglers towards that end, right? We've got a few people that said this and that, but most of the data is right here in this hump area, right? And so, so if something is, so the mean is always at 0. Okay, so most, again, most data is normally distributed if it's collected correctly, scientifically and methodologically sound, and yada yada. And so we trust that data that we are assessing will hopefully fall in this distribution. And we always assume that. That's our assumption always. So sometimes it tends to be a limitation, but that's our assumption. So the mean is always at 0. So we're assuming that here we have our mean of 63.4. It's right here at 0. And we're saying that at one standard deviation of 2.6. So we're saying we go over one standard deviation on both sides. This difference is 2.6, and this difference is 2.6. Okay? So, so 63 plus, what was it, 63? Yeah, 63.4 plus 2.6, that's 65 on this side. 63.4 minus 2.6, 63.4, 2.6, that's 60.8, right? So within one standard deviation, and you'll see here, within one standard deviation, so plus or minus 1, so you're going 1 this way, 1 that way, you're going from 63, which is our median, you're subtracting by 2.6, our standard deviation, subtracting by 2.6, our standard deviation. Now we're actually looking at a range. So within one standard deviation of our data, of our mean, we have our range is that, what did I say, 60.8, and our data ranges from 60.8 to 65, 60.8 to 65, right? 60.8 to 65, so 68% of our data is really right here between, I would say, 61 and 65, and that makes sense. The majority of our data is between 61 and 65. Yeah, that's 2/3 of our data. If we said, well, what's the range for 95% of our data? These numbers are tried and true. These numbers are calculus-based. These numbers are proof-based. So this is not something that we do in this class. This is something that you go, okay, I believe you. Because that's just what we do, right? These numbers are set in stone. Every person uses these numbers. This is not just for this class. This is for every standard deviation interpretation, right? So one standard deviation is the majority of our data, 68%, 2/3 of our data. Two standard deviation gets us out to 95% of our data. And we can see that we've got about 2.5% here, 2.5% here, right? So extra little tiny bit left. But if we wanted to ask, if I asked you for the how spread out it is at 95%, how spread out are 95% of my data is, right? Then I would go out too. So where I had the 63.4, now I went out 2.6, right? At 60.8, then I went out 2.6 again, right? So now let me just get a calculator because I'm tired of doing this on with my brain. So we had 63.4 minus 2.6, 60.8. Then we went out another 2.6, 58.2. So standard deviation, so 95% of our data, the first point is 58.2. The second point is 68.6. So even there, we can see that our data doesn't even go that far out, right? 58, That's well outside of our data. So really it's telling us that our data really is just right there between two standard deviations of the mean. Okay? And then of course, if we wanted to know what 99% of the data falls within, then we would do 3 times the standard deviation. And here it is listed a different way, but it's really the same thing. We're saying, you know, I like to do things in various forms so that if you don't understand it one way, you might understand it the other way. So there are 3 empirical rules for interpreting standard deviation. If the values of a variable are approximately normally distributed, as we talked about, the bell curve, then the following rules hold. Approximately 68% of the observations are within 1 standard deviation. So then you would do mean plus the standard deviation, that's the higher end, the mean minus the standard deviation, that's the lower end, right? So then that range, just like we do with a regular range, max minus min. If it's 95% of the data we're looking for, then it's the mean plus 2 times our standard deviation, mean minus 2 times our standard deviation, right? So again, and here's an example, and it just popped up out of nowhere. But here's an example. We've got a mean of 45, and we want to know, well, if the standard deviation is 15, then how spread out is our data? 68% of our data, right? Then we do 48 minus 15, 48 plus 15. So our data is spread out between 30 and 60, or 30. If we're talking about 95%, then 45 minus 2 times 15, so that's 45 minus 30, right? So it should give us 15. 35 plus 30 should give us 75. So the range is from 15 to 75, right? And then we can do it for 3 standard deviations. Okay, so again, this seems like a lot. Range is max minus min. IQR is the midway point for the first half, midway point for the second half, right? And now it hovers around the median. And now our standard deviation looks at the mean, and it looks at the range around the mean. Literally, that's it. So an outlier is literally, I must like that word literally, is literally a value or an entire observation that lies well outside the norm. Statisticians disagree on an exact definition of an outlier. You might define an outlier as any value more than 3 standard deviations from the mean. Definitely, I would. But this is only a rule of thumb. Sometimes an outlier is easy to detect and deal with, especially if it's visually and if you have the right scales. We've talked about those scales. So sometimes a careful check of the variable values, one variable at a time, will not reveal any outliers, but there still might be unusual combinations of values. And probably the best advice for dealing with outliers is to run the analysis 2 ways, with and without the outliers. I do that all the time. That's a perfect test, because if the data changes drastically, then you know, wow, that number must have had a big influence. And so when I removed it, look at this, like it's totally different. So the best way to sum up a variable, these are just rules of thumb. I'm corny. I love being corny. So I think that's it. So that's it for lecture 2. Make sure you use these Excel functions when you do your equal sign, equal max, equal min, equal percentile, right? Use this, right? And standard deviation S means sample, standard deviation P means population. We are not dealing with population data, so we use sample. All right, hope this was helpful. You can read this on your own. Cheers, everybody.